Hello everybody. In this video, we are going to be dealing with translations and reflections. So we would really want to look at the parabola for this one because there's a lot that goes on with the parabola in terms of this topic. So in the turning point form that we have here, so we have y is equal to x minus p all squared plus q. So the p represents the horizontal shift. So this is kind of a revision from the parabola, right? Grade 11 parabola. We've been introduced that the parabola can now shift horizontally. However, there's a little bit of an extra step that we can use in order to check whether or not it shifts to the left or to the right. The q represents the vertical shifts. So we know that if the q is negative, so negative indicates a left shift, okay, and then a positive value indicates a right shift. Okay, but what about p? Well, in this case here, we first need to do like an extra step first, right? We see that we have x minus p, but that's a bit weird. So we want to get it in the form of x is equal to p, okay? So in order for us to do that, we'll have x minus p is equal to 0. We'll actually let this be equal to 0, such that what we do is we say x is equal to p. We take the negative p over, and now we have our x value that shifts, okay? Cool. So in order for us to know whether something shifts or not, we need to look at the sign once again, but we're only going to look at the sign of this one. So if it's negative, let's start over there. If it's negative, then it'll have a left shift, and if it's positive, once again, it'll have a, do the arrow, it'll have a right shift. Okay. So obviously the value will indicate how many units will shift either to the left or to the right, and depending on the sign that we get, you will know. Okay. And then if we look at the reflection, which we'll actually tackle on later in this video, if there's a reflection in the x-axis, so think about it this way, the x-axis is horizontal, then the only thing that's going to change is our y values. Because think about it, right? If we have some x-axis, and let's say, for example, that this is our x-axis over here, and then we have some y value, let's say, for example, the y value is obviously going to be positive. And if we are going to reflect it about the x-axis, that means we are going to reflect it around here, and then that y value that we initially had becomes negative. However, the x value will stay the same. Okay. So it essentially looks something like this. So we can just shift this over here for this part of the understanding. Okay. And if we're going to look at the one underneath it, notice that the reflection in the y-axis indicates that the only thing that changes is x. And that makes sense because now what we're going to do is we are going to do this. Okay. We are going to have so this was obviously the x-axis, best to say that. And this is the y-axis. And let's say, for example, we have a positive x value. So let's say positive x is over here. And then we are going to reflect this about the y-axis. And then what's going to happen is we are going to shift it to the negative. And what you notice is that the y value actually stays the same. Okay? Because all we're doing is we are changing the value of x. Okay. Great. And then this is just going to be negative x and y. And this is going to be positive x and y. Y remains unchanged. So that is what we mean by when we reflect in the x-axis, we just negate the y sign or the y value. And when there's a reflection in the y-axis, we negate the x value. Okay, let's do some examples. Okay, so here's the first example that we have, right? So we need to sketch the graph of f of x equals to x squared. Then on the same set of axes, we need to sketch the following. Number A, we need to sketch f of x minus 2. And then number B, we need to sketch f of x plus 2. So first things first, let's actually look at A and B, okay? So it says f of x minus 2, meaning that wherever we see x, right? So notice we have f of x alone, but the only change is that we have x minus 2. So whenever we see x, we need to replace it with x minus 2, meaning this will be x minus 2 squared. And then the other one, it will work the same way, with x plus 2. Wherever we see x, we'll replace it with x plus 2 squared. So do you notice that the only change that we have is that p-value? There's a shift, right? Over here in this case, there's a shift. So let's indicate it by colors. Let's just do colors, right? So now the first one, let's leave it as red, but the second one, let's make it maybe dark green. And then maybe we can just change the color of this one, honestly. So we can change this to blue. And then the function that we have over here, which is f of x on itself, let's change this to red. Okay. Cool. Now we have color coding. So we are going to draw the set of axes. So we should be able to describe the transformations from graphs by now. So notice that there is no such thing in the first graph as a q value, right? There is no q value. The q value is actually 0. If it doesn't exist, then it must be 0. Or if it's hidden, it must be 1, right? If it's a multiplication by something, a coefficient. So in this case, we know that there is no shift vertically. So the q shift, it's a vertical shift, and it doesn't apply here either, and it doesn't apply here either. So therefore, it will just have a turning point that exists on the x-axis. Okay. Cool. Now, what we do with the actual shifts horizontally, remember what I said? We take the inside of the bracket, we equate it to 0, and then we see what is the x value actually equal to. Then that will indicate what type of shift it is. So if we look at the first one from number A, notice that we have x minus 2 equals to 0, which implies that x is equal to positive 2. So notice that this is a positive value, meaning it's going to undergo which type of shift? If it's positive, it will undergo a right shift. And then if we look at the second one, which is number B, I know we're working with both of them at the same time, but it's actually kind of easier this way. If we look at it this way, x plus 2, we have to equate it to 0 so that we can see which shift it is. And then we can say, yeah, x is equal to negative 2. And because it's a negative value, we are going to shift it to the left. Okay. So we're going to draw our original one, which is y equals x squared. So here you go. It looks something like this. Not perfectly drawn to scale, but it's something. So here is our f of x. Okay. Then we need to draw the shift for f of x plus 2 and f of x minus 2. So the one that has a right shift, which is number A, which is the blue one, that one shifts 2 units to the right. Therefore, what we are going to do is we are just going to shift 2 units to the right. Let's assume that 2 is somewhere here, okay? So this is the value 2, which is positive 2, and obviously this value here must be 0, okay? But within high school, you kind of need to write down the full coordinate. So this is an x-intercept, so it'll be 2 and 0, okay? And then this one here, things tweaking. All right, let's try that again. This one here is going to be the origin, okay? And then we need to obviously draw this parabola first. So notice it's the exact same type of parabola, okay? So who knows what type of intercept it's going to have. So I hope we can be able to draw a nice looking parabola. You know what, that's good enough. And then here, we are going to have the green one, which is the left shift by 2 units, okay? So here we go, let's put this over here, and then this coordinate is just going to be negative 2 and 0, okay? There we go. We have the left shift. Not the most perfect parabolas, but it's something. So there we go. So the blue one is obviously f of x minus 2. And then the green one is going to be f of x plus 2. Okay. So this is what we mean by translations and shifts, right? This is the translating graph, and we are going to be shifting to certain units. And if it was a case where we had a q value, we would shift it vertically. Alright, so examples 2 says, given the function f of x is equal to x minus 3 all squared plus 4, number A says, determine the turning point of f. Okay, and then number B says, determine, that's a very interesting G placement, determine the turning point of g of x if g of x is equal to f of x minus 1. Now this G is here as motivational support, so I'm going to leave it here, okay? This just proves how amazing I am at spelling, and this is why I took mathematics and not English as tutoring. So, in this case over here, what we are going to do is we need to determine the turning point. Now we know that this is the turning point form, right? Where the turning point is essentially going to be us saying that the following form for turning points will be as follows, right? So with turning points from turning form, we are going to have x minus p equals to 0, and we are going to have q, okay? So this is a very funny looking coordinate. However, this does make some sense. All we're going to do is take the inside of the bracket, let it be equal to 0 so we can determine our actual x value for the turning point, and then the actual y value for the turning point is just the q value. Okay, so notice that just shows the simultaneous shift in the horizontal and the vertical style. Okay, and then that is where your maximum or minimum value will be. So we notice that this is clearly going to have a minimum value, because notice that the a value that we have here is 1 and it's positive, so it's concave up. Okay, so it has a minimum. So in this case over here, if you're going to answer number A, then therefore the turning point is just going to be what? X minus 3 equals to 0, and then the q value is positive 4, so therefore the turning point is just going to be x equals to 3, so meaning it's just going to be 3 and 4. Okay. Because remember, this is just the coordinate, okay? And then once you find the actual x value, then you just place that real value in here. So what you'll end up noticing is that every single time when you place this in as a shift or into the turning point, we always swap the sign. If you'll notice that when we put this in the equation. So if it was x plus 3, then it'll obviously be x equals negative 3, then the turning point would have been negative 3. However, this one is x minus 3. So meaning x will be equal to 3 in that case. So if you want to do a shortcut way, you don't have to do all of this. You can just take the 3 and then change the sign. Okay, so it'll go from negative 3 to positive 3. There we go. So there's the turning point. That is how you find it. So let's move on to number B. Number B says determining. I love that word. Determining turning point of g of x if g of x is equal to f of x minus 1. Okay, so f of x minus 1 is essentially us saying that it's f of x, but we are going to replace the x with x minus 1. Okay, so if you look at it in this perspective here, it's going to be b, where we have f of x minus 1 is just going to be equal to nothing but x minus 1, right? Just kind of put it in the bracket there. And remember, it's minus 3 squared plus 4. Okay, so notice that all we did was we substituted x for x minus 1. And then notice that we are just going to get something along the lines of x minus 4 squared plus 4. Okay, so what do you notice from this? We can clearly see that x is being manipulated by negative 1, meaning that we are shifting over here. Okay, we are shifting by 1 unit. In this case, because it's a minus 1, we'll obviously flip the sign and then say that we are going to shift 1 unit to the right. But we can clearly see when the simplification, we can see it's going to shift 1 unit to the right, okay, from the original. So notice that the turning point now will be the following. Turning point is going to be this value, but the sign is going to obviously flip. So if it's minus 4, it's going to be positive 4 over here, and then the q value still stays the same. Nothing changes for that. Okay, it's nothing too crazy. This is just indicating the shifts when it comes to either horizontal or vertical style within parabolas. Alright, so we have example number 3 that says describe the shifts if f of x is equal to x squared, where g and h share the same concavity as f. So first things first, that's a lot of information. So we need to describe the shifts. What exactly is happening here? Let's look at the coordinates for this one. Before we analyze the coordinates first, we do need to note that it does share the same concavity, meaning the a value throughout all functions is exactly the same. Okay, meaning even though this isn't drawn exactly to scale, we can clearly not deduce whether or not these have the exact same shapes. But because we're told that it has the same concavity, then therefore it should have the same shapes now. Okay, so I hope that makes everyone happy. Because I almost didn't include this, but I realized, you know what? Yeah, let's do this. So we can clearly see that the original function, which is f, is the red one. And it has the origin where the turning point is, okay? And notice that the turning point for g, which is blue, is just at 0 and 5. And then the turning point for h, which has 0 and -6. So notice that the only shifts that are taking place, because the x coordinates are staying the same throughout, is going to be what? It's the y values. It's the vertical shifts. Meaning all these graphs, both these graphs g and h, are vertically shifted either up or down. And notice that g is just shifted up by 5 units. And then where h is shifted down, but by -6. So 6 units it's shifted down, okay? So therefore, all we are going to say is that we can see that g of x is equal to x squared. Remember that we can deduce that this is 1, which is the same as f, because they told us, which is going to be plus 5, because we can clearly see that it's shifting up by 5 units, and if we're shifting up by 5 units, that q value is positive 5. So this is just an example, well, I guess maybe tell that afterwards. G of x is equal to x squared plus 5, but notice that x squared is the same as f of x. So this actually just implies to us that g of x, the shift is just going to be where f of x is added by 5, right? We're shifting the function by 5 units. What I was trying to get out of this question was showing what is the relationship, not just by giving the function's expression, but also by showing the relationship between g of x and f of x. And we'll do the exact same thing with h of x. H of x is equal to x squared. Notice it's going to be -6 because it's shifted down by 6 units, or it's at this coordinate. It has that turning point. This implies that h of x is just the same as f of x, but we are shifting 6 units down. It is -6. So this is the relationship between the two graphs. So we just described the shifts in terms of mathematics. Obviously, this indicates that we can say here, G is the graph of f shifted up by 5. Okay, you can obviously say units. And then over here, we're going to say H is the graph of f, which is shifted down by 6 units. Okay, cool. And there we go. That's what we mean by describing. We need to specify what we are seeing, and we need to tell the examiner, look here, I understand what's going on, so here's the relationship between them, and this is exactly what's going on in real words. So you need to show the mathematics, and you have to show the words behind it. Okay. Alrighty, so example number 4, which is the final example we're going to do for this video. The graph of f of x is equal to x plus 2 all squared plus 3 is given. Sketch the graphs of f, g, and h if g of x is equal to f of negative x and h of x is equal to negative f of x. Now, from this one here, we clearly need to sketch all three of them. And we need to see over here, what is the difference between them? Okay, so I'm adding my own question here and saying describe the relationship. Okay, so here we need to also describe the relationship between f and the others. Okay, so that's the way I'm going to phrase this question. So first things first, we need a Cartesian plane. Let's do this. Okay, I think this is a little bit too small. Let's make it bigger. Okay, now it's bigger. That's good. So first things first, we need to sketch it. How do we sketch this? Well, I'm going to say for this example, we don't really need to look for the most accurate sketches. I just want to look at the most important parts, okay? So what is the turning point of this function? Because you kind of need the turning point over here. We know it's concave up for f, but we do need the turning point. So let me shift this graph, though, a little bit to that side, so that we can obviously have space to write down things, okay? So here, the turning point for f of x is just going to be what? We change the sign of positive 2 to become negative 2. So this is our x equals negative 2. And our y value is going to be 3. Meaning the turning point is negative 2 and 3. So it'll lie maybe somewhere, let's say here, right? Let's just assume that it's somewhere here, okay? And we'll call this orange. Okay. So this is negative 2 and 3. And then from here, this is the most least accurate graph I've ever seen, but it's fine. This is f. And now we also need to note that we have to also sketch the graphs of g and h. And g of x is equal to f of negative x. Now let's quickly do the mathematics behind that, okay? So let's make sure that g is blue, maybe. Let's do it like that. So g of x is just the same as f of negative x. And we know that wherever we see x, we need to replace it with negative x, okay? So this is what we're going to do. We are going to have negative x plus 2 squared plus 3. And what you would notice in this case here is that every single value of x that is inputted, the sign is just going to change. So if I plug in negative 2, notice that the output is going to be positive 2, okay? So that is just going to indicate a change of input values, okay? So we are going to negate x, and whenever we are negating x, what axis are we actually rotating about? Well, that would be g, right? Because whenever we're changing the sign of x, that means we're reflecting about the y-axis, okay? Meaning that we are going to notice that the x values will change to a positive. Therefore, we can see the following, that 2 is going to be somewhere here, the positive 2, so now it'll be positive 2 and 3. And remember, the y still stays the same because we're not changing it, okay? Then it will look something like this, okay? So notice that this f of negative x just indicates reflect about y-axis, okay? Whenever x is negated. Now we have h of x, okay? H of x we'll do in green. We can see that y, which is f of x, obviously, is being negated, meaning we need to, for this one over here, reflect about the, which axis? X-axis. Okay. And notice that when we look at the graph of h of x, we are negating it, meaning that it's going to be negative of x plus 2 squared plus 3. And then this implies that h of x is just going to be equal to negative x plus 2 squared, and this will be minus 3. So notice what's happening is the concavity is going to change for this one over here, and also we are going to shift down by 3 units, okay? So remember we translating it to f, meaning we are going to shift 3 units down. So and then we're going to change the concavity, okay? So it'll be somewhere here. Okay, and this will be h. And then this value will, because the x-axis, the x values are still the same, but what we'll notice is that the y value is now negated. Okay. So there we go. Now, how do we describe the relationships between them? Now, what we're going to do for g of x is the following. We are going to show what they gave. We are going to show over here that g of x equals to f of negative x implies to us that this is an arrow, by the way. It implies to us that g is the graph of f reflected about the y-axis. We're just describing what we have done, okay? And then if we look at the graph of h, we can clearly see that h of x equals to negative f of x. We're going to describe this from what we've transformed, right? H is the graph of f, first of all, reflected about the x-axis and a negated concavity. I was trying to find the words in between here. Concavity, it makes more sense because we obviously change the sign of the concavity, meaning we're flipping it around. Okay, you can obviously, you'll obviously get a mark if you talk about the concavity. So if you say the concave changed or something like that, right? As long as you mention the change of concavity, you should get a mark for that. And also a note about the reflection, about the x-axis. Okay, and that is what we are going to learn about the transformations and reflections.